Go ahead, Pam.
Well, you know there's 40, so it's the opposite angle.
Okay, oh, just you only get to one. Okay. So we're going to use the opposite angle theorem. So this right here. Okay, so if you do two things like that, that will work. Okay. Can somebody else please? I'm making a mess here. I'm gonna go ahead.
The Z pattern.
Oh, good. Did I show those congruent? I should have showed those are parallel, didn't I? Do I know those are parallel? I not say those are parallel. Do I need to say those are parallel? I think I do need to show those. I do need to say those are parallel. I think. I probably should have shown those are parallel. Because the thing is, if they're, because just think, if one's like this and one's like this, they wouldn't work, right? So they'd have to be parallel. So, can I go here, please? So, what we said is here, I'll say, we'll use a Z here, maybe. And that's going to show about 70 degrees, just like that. And then we'll do another Z pattern in black. Okay, so if you're saying to yourself, I don't like the Z pattern, what's another way I could have got the third angle? Sorry, I'm going to stop you for 1 second. Somebody else here. Yeah, go ahead. Very good. So I hope everyone heard that, guys. Because one of the things they'll do, people like to do is they give you two angles. You got to find the third here for that. Okay, so it's very, very possible that'd be an opportunity there too as well. Okay, I'm going to give you now example 3, where life starts to get fun. Yeah.
So if it's somewhere and the angles are the same in both triangles, then what happens if it's congruent?
If it's okay, good question. Going back to example 2, what would have to make that congruent? What would I need to know that to be congruent? One of the sides then, okay? Because think, if I make a shape like this, what shape can I make? Let's make a diamond, okay? There's a diamond, okay? Now, I have bigger hands than you do. If you try to make that diamond, your diamond will be smaller. It's still a diamond, right? So it's just similar, right? In order for it to be the same, you'd have to have the same size hands as me for that to happen, right? That's using that. But as far as this goes, you'd have to know the sides are the same. Okay, so just one, because this is where we talk about angles, side angle congruence, right?
Oh yeah, because it's a 70-degree angle, only two sides.
Yeah. Okay, so here you go. This question is a little bit trickier here. So please put a star in your heart for this. So it says here, prove the triangles are similar, and then solve for x. Okay, now this one's nicer because we're getting variables and algebra back in here, and you know how I love algebra, okay? Now, we have to get, I only see one triangle, that's my issue. And this is the thing that stumps my class every single year. Can someone be brave and tell me why there would be two triangles? Derek, go.
There's also the other side one.
Yeah. So what I would do, and Caleb, I'm going to strongly encourage you to do this. Okay? I'm going to redraw this as two triangles. So I'm going to draw one little triangle and one big triangle. Sort of like that. Okay? They are, and we'll show you why in a second. Okay, we're all good on that, where those two came from? Can somebody give me the side lengths of the little triangle and the big triangle, please? Go ahead.
So the big one,
Yeah.
12
Where?
on the long one.
Okay. Which one's that?
It's
This one?
5 plus 7.
Oh, this one left, I was hoping you'd say. Okay, good.
And then 12, and then
No, the
12.
bottom, good. Okay, for the little triangle. What do I do for the little triangle? 7 and 7. 7 and x. Now, what we're going to show is that should be 7 if we can show those are similar. If we can't show the triangles are similar, we can't just say 7 and 7. Like that's where we get in here. Okay, let's start with the, because what we need to do, we need to prove that all three angles are the same. How do we show that the top angles are the same for both of them? They're both the same thing, okay, right? They're both on top of each other. So this is just going to be theta, I'm going to call it. Right, these are just same angle, right? They just mean this, they're right on top of each other, they're the same. Okay? Let's do the angles on the left. So what I need to show is that I have this angle here matching with this angle here. Yeah, I should have mentioned that. I said it, but I didn't actually print it. Where are all my markers going? Yeah, so I actually said I didn't write it though, but yes, these two should be parallel there. So they have to. Okay. If those two are parallel, what other angles can I show that are the same? Calvin, go ahead. That's fine, very good. Okay, so what I'm going to do is I'm going to make a little F like this. And I'm going to call that beta maybe and beta. It doesn't really matter what the numbers are. Okay, so on the big triangle then, this bottom left one's beta, and that bottom left one's beta. Does everyone see what I'm trying to do here? Okay? No, the numbers don't matter, right? Okay, and again, and can somebody give me the suggestion for the last one? Do exactly what Calvin just did again, okay? So I'm going to do the same thing on the right side and do. Now, for those who don't speak upside down math, okay, if you need to flip your page over to see the F, go ahead, right? The F, as you can see, can be flipped any sort of way here. So that means this and this. Are we sort of okay on that logic that's happened so far? Now, I can just tell in my mind that the bottom is going to be 7 because I'm a math teacher, okay? But the way I would actually solve this, if I was a student, okay, I would say this. I start with my x. That's my unknown. What side corresponds with x on the big triangle? 12, which is the bottom, okay? So I'm going to say this bottom side here corresponds with that bottom side there. Okay? And then I'm going to say, well, my 7 is also on the little triangle, which is right here. What corresponds with that? Well, also 12. Okay? So this is a boring example because they all were the same. Okay, are we okay on where that equals thing came from? Okay, no. Because no?
Why are they equal?
Because they are. Because they're similar, right? Going back to here, we said that if things are similar, it means that, right, the idea is the sides are going to be in the same proportions. And that's what we did here, right, with the similar.
How is 7 worse than 12?
What's that, sorry?
How is like 7 worse than 12?
Well, it isn't though. What I'm saying is this, the bottom of this triangle is proportional to the bottom of this triangle. Right, that's what I'm saying. So the bottom, all I'm saying is the corresponding side to the x is going to be the 12 on this triangle. And the corresponding side to the 7 is going to be the 12 on this triangle. That's all I'm saying. Okay, so the x, what I used to do, I'll do this the same way I do my applied. Oh, goodness.
Thanks.
The way I do this in my applied class, when I teach this concept, it's like, okay guys, what are we doing? It's going to be little over big. Or big over little, okay? So what I just did was I picked two sides from a little triangle and put it in the numerator. The corresponding sides from the big triangle, put it in the denominator. That's just the idea there. Okay, so solving for x, then I would do it as x. How do I solve for x? Oh, yeah, come on.
Say it was 12, we try to make triangle have 15 and 7.
Yeah, and I'm going to do another one that's messed enough. Does that work out for me? Yeah, it will be 7. So it's good. Good. Okay, so x equals 7 times 12 divided by 12, which happens equals 7. OMG, I'm with you. Okay.
Oh, I got it.
Doctor.
Wait, why do you have to divide it when it says it's equal?
No, because it's like a fraction. It's okay, just because it's like a fraction, right? It's like a fraction equals a fraction, right? That's what it's supposed to be. Okay, I'm gonna give you one that's a little bit more complicated with different numbers. You get you guys to try this one out here for yourselves right now. The rule, what's that? The rule is for this, you have to show that it's similar before you can do this. The whole purpose of doing the similarity thing is that so you can get to this point. You can't do this without being similar, okay? All right. Example 4. Oops. Is this our last example? No. Solve for x. Let's do this one. X is going to be this one. Okay. I'm going to pause in the video and do your best. So those two things are parallel. Okay, so I would recommend strongly to prove congruence using the angles. Okay, so make all the angles the same on the big triangle, little triangle. Now we did an example like this with numbers. There are no numbers in it this time, which makes it more tricky. If you need numbers, let me help you. The numbers I'm going to use are theta, beta, and omega. Okay? So start with make a theta, beta, and omega on the other side. Show where they come from. Okay, and then you want to get the sides related to each other from that. Okay? If you're totally stumped, you need encouragement, raise your hand. Okay, good. Okay, I'm going to pause on the video here. I'm going to help my tester. I sense a lot of stress here. I don't like stress. Having stress gives you a haircut like mine, and nobody wants a haircut like mine, okay? So, so the question was here, I don't know what to do. That's what I'm getting a lot of here, okay? And that's okay. We'll get this practice up. So, I'm just going to publicly say what Lindsay said. She goes, do I need to show you how I got this? Yes, you need to show me how you get each angle. So even if it's just as far as saying this is theta because of opposite angles. Okay, now is the omega going to, sorry, is the beta going to be top or bottom, and how do I know? So I'm from the bottom, why is the bottom, or is that? Z pattern. So I'm going to do this beta. Okay, so just to watch for why that is, someone said beta's on the bottom, because the idea is you're just doing this, right? Okay. And then the last one's going to be omega. And that's also. Yeah. So if, hey guys, please do this. If you want to break into 2 triangles and redraw them, go ahead. Okay, that's fine. I'm not going to because I'm going to be like Caleb, he's my best friend, so I'm going to just like Caleb. So what the question was here, can I please do this, guys? So I'm going to do like what we said before, and I'm just going to write little over big. Now this is the part that was confusing to some people. I'm going to start with x because I love x. That's what I'm actually solving for here. Now, what is the corresponding side to x on the big triangle? This is the tricky part that gets some people confused rather than guessing. How'd you get 12?
Well, I broke that into 2 triangles.
Oh, and then spun them around and all that stuff, and that worked nicely. If yeah, it's on the same line. The other way that I always think of it as when I was a student was x is from theta to beta, so theta to beta is going to be 12. Okay, so that's another way to think of it. Okay, so what I was saying is.
Oh, no, but I get it.
So theta to beta is x, and theta to beta is 12.
Wait,
Right.
so then.
Yeah, so then I'm going to use the other number. I know nothing with this side, so I'm going to put a 4 here. So that's another side of the little triangle. What's the corresponding side to 4 then? 13, right? Because that's omega to beta, omega to beta. Now, this is another thing that's getting people confused here. Okay, because you guys have turned your brain off algebra, and that's okay. Algebra is everywhere, so you have to use it every single day. I see fractions and I'm afraid. How do you deal with x divided by 12? What's the best way to get rid of that divided by 12? Alistair. Good. So x is 4 times 12 over 13, which is 48 over 13. I'm happy with that as an answer. If you want to tell me that's equal to 3.8642, don't. Okay, leave it 48 over 13. Why? Because I'm a mean human being.
No, but you don't say a length of something is 48 or 13.
I'm just going to yell at you personally. Do what? Yes. I don't care. So I said out loud. But I actually said it. Yes, I would. Now, I'm going to strongly recommend doing this stuff here tonight. Getting a good habit for this unit, because if you took a look at today's lesson, this was sort of weird, today's lesson, right? There's something sort of unique. So get this one a good start. I'm going to check homework in this unit because I want to make sure the life is good. If you are on the rugby team, okay, it's or the soccer team, please take responsibility for education too. That's all I'm going to say, and your coaches will agree with you. Yes? Yes, what's that?